Hi, Louis.
Hi, Bob. How's it going?
Pretty well. How are you doing?
I'm all right.
Okay, good. Let me introduce us. I'm Robert Wright. This is the Wright Show. You are Louis Crane, professor of mathematics at Kansas State University, where you do work on theoretical physics, among other things. And we're going to talk about a really fascinating theory you have. It is, on the one hand, a theory about physics, but unlike many theories about physics, I think it's safe to say it implies that life in some sense has a purpose. Is that fair to say?
Yes, that's exactly what's so weird about it. Yes, that's
Good.
exactly right. In a very precise sense of purpose,
Okay.
but and completely within a sort of a scientific framework. Uh,
It's funny.
okay,
I find it's very hard to convey to people that it's possible that life has a purpose, a larger purpose, even you could say in some sense a higher purpose, but a purpose that's totally compatible with the laws of science and a
that's
materialist. Right.
yes, that's right. That's right.
So we,
That's
we
what's so odd about it.
we have the
Yes.
same challenge in communicating with people. So let me set this up. Let me set the background for this. I became aware of your work by talking to Lee Smolin on this very website. You know of his work. You may know him personally. He's a very well known and very creative physicist. Now, he has a theory called cosmological natural selection, which is that universes replicate themselves much as forms of life do, and if they and presumably they replicate themselves, I think, through black holes in his scenario, and that implies that as time goes on, universes would develop properties more and more conducive to replication, just as species do, and some of those properties would include creating a bunch of black holes and some other features that are conducive to the creation of black holes, like enough stability for the universe to stick around for a long time, and so on. So that's his theory that universes are optimized, including ours, for forming black holes. Now I asked him in the course of the conversation, have you ever thought about the possibility that intelligent life could play a role in the replication, so that like our civilization might get smarter and smarter, and eventually so smart it could engineer the replication of another universe? Because to my mind, if that were the case, that might help explain some properties of life. And at that point he told me that he said, I have some bad news for you. That's not an original idea. Louis Crane has thought it up, and he also mentioned a cosmologist named Edward Harrison. I gather you two independently, without knowledge of each other's work, came up with similar theories.
Okay. Well, Mr. Harrison's work is it's very different from mine, and I wasn't aware of it at the time. But he imagined some altruistic future civilization creating universes because they wanted to create life.
Okay.
So that's got very little to do with my picture.
Okay, what they have in common, though, is that life plays a role in the replication of universes.
Yes, exactly so.
Okay, so uh, at this point, maybe I guess I'll let you take over. I mean, well, what? Let me ask you this. As I said, Lee Smolin's theory explains certain things about the universe. Do you think there are additional things that can be explained if indeed life plays a role in the engineering of the replication of universes?
Oh, yeah. Well, okay. In the first place, I should say that I was reading drafts of Professor Smolin's book and giving him feedback.
Mm-hmm.
And, well, to be blunt about it, I didn't really buy his argument that the universe that we're in is fine-tuned to maximize black holes by natural processes.
Mm-hmm.
I thought it was, well, I'm a mathematician, and when a mathematician looks at a physicist, they very often say, sloppy argument, right? And I thought there were some very bad technical arguments there, and I don't buy it. I really didn't buy it. Okay.
And this is back in the 1990s, right?
That's right.
Because
This is quite,
you
okay, there are two phases in the development of my idea.
uh-huh.
This is the first phase, the meduso-anthropic thing. And then there's, well, okay, I'll just talk
This
about
is the
one
name
phase.
of your theory. It's the meduso-anthropic principle,
Yes.
And the current incarnation of that theory is a 2010 paper called Possible Implications of the Quantum Theory of Gravity and Introduction to the
Yes.
Meduso-anthropic.
And a few related papers.
Okay.
I have a small oeuvre on
We will
this.
link to that and also to your original 1994 preprint that kind of evolved into that.
Okay, but so I decided I wasn't really convinced that we were actually maximizing the number of stars that would be produced by natural process. And
Now, let me just interrupt you. Is maximizing the number of stars, is that related to maximizing the number of black holes?
oh yes,
Okay.
the natural process for producing a black hole is that a sufficiently large star collapses and forms a black hole.
Okay.
So the idea would be that universes with those constants would have more babies. And so if the coupling constants of physics somehow survived through the process of collapse, and then to the other side of the singularity in the black hole, then universes would evolve to have these properties. That was Lee's argument.
Mm-hmm.
Now, but what it seemed like to me was that if you look at the world we live in, what's really screaming at you is that it's fine-tuned for life. We're so improbable. I mean, when you study science, you don't ask like whys in a larger sense. You just study what things are. But then if you start looking through the different sciences, there's all these incredibly improbable coincidences without which we wouldn't be here.
What's an example?
Okay, an example would be that we live in a galaxy which has spiral arms. Now, the spiral arms, are waves of star formation. And if you do the calculation based on
Are you referring to the familiar pattern we see when we see pictures of other galaxies? The kind of a pinwheel kind of thing.
That's right. Now, the thing is, if you just look at the matter that we know of in those galaxies, those structures should not be stable. And the thing is, having generation after generation of stars gets you up to the point where you have enough heavy elements that eventually the planets could have life as we know it. So if you didn't have something holding that galaxy in shape so that it goes on producing generation after generation of stars, we wouldn't be there. And then there's things like the fact that the Earth somehow stays within this very narrow range of temperatures for billions of years. It's not only fine-tuned to life. Life seems relatively simple. We got life within 300 million years, bacteria. But getting all the way up to intelligent life. Now,
takes time.
Well, not only it takes time, but also life stabilized a number of times earlier on, and it got into a sort of an evolutionary dead end. And then something came and destroyed almost all of it, and then it started again. And it took quite a number of cycles like that to get up to the point where you have mammals with big brains. I mean, we could have just gone on, reptiles all the way down until the sun went, but we, something outside just disturbs us just often enough. And if we didn't have a great big planet, Jupiter, catching most of the comets that come in, it would have been destroyed so often there wouldn't have been time for anything to evolve very much before it was destroyed again. So there's a fine sort of balance there. And then, of course, there's the balance in the carbon cycle in the stars. We produce a lot more carbon than you would think because of a delicate balance in nuclear physics.
Okay, now can I just interject? So these kind of like narrow ranges that certain things kind of seem to have had to be in order for life to evolve have been lumped under the phrase the anthropic principle, right? The idea that the universe.
I'm sorry, that's not precise language. The anthropic principle is an attempt to try to explain this.
Okay.
Okay.
Right.
You could just say, okay, we don't know why they should be like that. They're excruciatingly improbable.
Right.
But maybe there's just zillions of universes and we happen to be in the one. So it's
Yeah.
I do not like this explanation.
Yeah, let me just make sure we flesh that out. So, in other words, somebody comes along and says, "Whoa, how amazing! The universe seems fine-tuned so that life could exist. It seems just highly conducive to the existence of life." And they might be thinking, so maybe there's a God who made it, or whatever. It's meant for us, or whatever. And then the other person says, well, wait, that's a tautology. Obviously, the universe is conducive to life because we are here to think about it. So it has to be conducive to life. For all we know, there's a billion universes where there's no life, and so it's not so amazing after all. That's the dialogue that happened under the rubric of the anthropic principle. And
Yes,
go ahead.
I do not like this argument at all. I mean, it's just saying it's so because it's so. I mean, it's giving up the possibility of any sort of explanation. And there are all kinds of things on Earth that are equally absurdly improbable, and yet, of course, we take them completely for granted. The chicken egg isn't just a little bunch of yellow goo, but somehow it's organized down to the individual molecules, and it turns into a chicken. Now, what's the probability of that? But nobody thinks that's amazing, because we know there's been a long sequence of chicken eggs and chickens, so it's fine-tuned
through natural selection.
That's right.
The improbable but functional traits are preserved by natural selection, and there may have been tons and tons of mutations that were less functional, and they are discarded. So in that view, it's not so miraculous.
That's right. So you see, this raises the question, could human beings possibly affect this cycle of universe building? And so the answer is human beings could, if we could produce black holes, artificial black holes. Now, when I asked this question, the literature on producing artificial black holes had exactly 0 papers. Nobody had ever thought about how to do
humans engineering black holes.
That's right. There was 0.
Which in your scenario could explain all the fine tuning. If indeed life is a prerequisite for the replication of universes, that would explain why over lots of time through the selection of universes, you get universes fine-tuned for life because only those replicate.
That's right. Right. So that was my first step. So it would say that human life, and I don't mean on an individual scale, but as a whole, has a purpose in the same sense that a chicken's egg has a purpose. Mm-hmm. The purpose of the chicken's egg is to create a chicken, and it developed that because of cycling. So our universe was produced in a very, very fine-tuned way as a result of a very, very long cycle, and we sit within that, and therefore we and the universe around us are fine-tuned. Now, this doesn't have to be optimistic, I'm afraid to say, because let's just think about fish eggs, okay? About 1 fish egg in 400 becomes a fish.
Right.
So we could easily be a slightly defective egg, you see, that never becomes a fish.
Right.
And when I read the newspapers, I think about that.
Right. And in other words, it could...
Yes.
In other words, so it could be that, yes, our universe is well engineered to replicate itself through the intervention of life that the universe produces, but it could also be the case that the way the system works is there's planets all over the universe with forms of life that emerge, but most of them actually blow themselves up like right about now, but as long as one of them doesn't, then the universe can be replicated, right? So,
That's right.
So we could be one of the many that are going to blow themselves up. And I have to say, that seems to me right now like a more probable scenario. I'm not kidding. I mean, but anyway, we don't need to get into that. But
no, it gets much spookier.
Oh, good.
Because it's possible that if people were aware of our purpose, it would change their perspective.
For the better or worse? For the more or less likely to replicate?
To more likely to replicate.
Oh, good.
If they realize our life has a long-range purpose.
Right.
I think we have an instinctual drive to find purpose. People don't want to be happy. They want to be useful. They want to sacrifice themselves. So that's because groups of human beings survived because people were willing to sacrifice themselves for the group. But I could imagine this coming into play on a larger scale if we realize, I'm doing, by studying mathematics and physics, and by trying to make our world survivable, I'm doing the work of the universe in replicating itself, which sounds painfully like God's work, doesn't it? I mean,
it's a living,
Yeah.
It's a
But
job
I mean,
somebody's got
so
to
in
do.
other words, studying science, being careful with our planet, could lead to a distant future where we manage to achieve things that are otherwise beyond our imagining. That we can, okay, so.
And I should add, lots of other things could fall in that category, like reducing the amount of hatred in the world, right? Being nice to people in ways that are conducive to peace and harmony as opposed to blowing up the world, or making policies that are conducive to the survival of the world. There's lots of tasks that could fall in.
Yeah, but I mean, if there were an overarching sense of purpose, but one that, I mean, the trouble is we have so many overarching senses of purpose, and that's usually what people fight over. They have two slightly different overarching sense of purpose, and there's no way to resolve them, and they end up,
So you mean like for example, national purpose, my country's better than yours, or whatever?
Yeah. I mean, you might have two countries, each of which feel that their purpose is to create a peace in the world. And they say, no, we want to create a peace in the world. No, we want to create a peace in the world. This is stupid, isn't it? It's unbelievable. And they end up blowing themselves up because each one wants to create the peace.
Yeah.
That almost sounds realistic, doesn't it? But so
sounds
if there's
familiar.
Yeah. But if there's something that's objective, that's rooted in our understanding of nature, that tells us we have this huge goal, but we have to work together on it for a very long time, I could imagine this changing the outcome.
Mm-hmm.
So, I mean, I don't see myself as cut out to be a prophet of a religion, but this possibility just sort of emerged while I'm, thinking about physics. And it's sort of it's not what I really do mostly, but thinking about this strange little intellectual line that Lee Smolin sort of dragged me into. And then when I told him all this, he looked at my ideas and he totally chickened out. He said, that's too spooky, and he went back to
we talked about that when I had him on the website, and he was kind of candid. I think he even used the word tactical or strategic. He said, like, look, as a tactical matter, I'm having enough trouble getting people to take my theory seriously. Like, if you start throwing in that it explains, life and we are involved in the replication of universes, then it's almost hopeless. But so this is why I called you.
Okay. So anyhow, like that was the first stage in the development of my ideas.
Mm-hmm.
Now, after a couple of years, I gave a talk in a philosophy seminar. I don't know if you've had any contact with academic philosophers.
A little bit.
They're sort of like alligators. Okay, but
you shouldn't tell them that. That will further reduce the chances that they will accept your theory. But go ahead.
Okay. No, but I mean, so one of them came up to me afterward and he said, "Well, I'm not that impressed. What we do is prove things, and I'm interested in proof. So how would you prove it?"
Actually, a lot of philosophy isn't about proving things, but I digress.
I know. Okay, that's what he said.
Yeah.
Okay. Anyhow, so I just, I said, well, I'm just a poor dumb mathematician. What do we know about proof? But
Yeah.
But actually, it made me start thinking, and then it went back into my unconscious mind, and I went on working on what I usually do, and then I realized that there is a way to try to test it, because the theory makes two predictions.
Okay.
They are non-trivial predictions. The first is that it is possible to make an artificial black hole. Nobody ever thought about it. And the second is, it's useful. We would actually want to do it. It was 10 years after stage one of the meduso-anthropic principle, which is named after a jellyfish, in case you care. But
and it's about the life cycle a jellyfish goes through, a kind of some kind of two-phase thing that is kind of a metaphor for this.
Yeah, that's right. That's right. I've been reading something about animals without backbones. Okay, but anyhow, so I decided to look into this. And there's a semi-classical theory of black holes that, they radiate.
I'll trust you.
The radiation is very small until they become very tiny. So they have a characteristic mass depending on their radius. They have a characteristic life expectancy depending on their radius, and they have a characteristic intensity of radiation. And those formulas are all in books. So it was a very, very simple matter to just do some back of the envelope calculations and see if there was a range of black holes that would be useful to us and that we could make with the resources in our solar system. And so the job would be small enough that we could do it. It would be big enough that it would last long enough to be useful. The answer could easily have been no. But just from some back-of-the-envelope calculations, and in fact, I did simple ones, and I had my graduate student at the time I don't know. I think he was a pretty lucky graduate student. The graduate students always come to the professor and they ask him, would you like to work on the n=5 case? I said, how would you like to work on a starship? And I didn't have to ask him twice. But he actually did the calculations in more detail, but they came out right. So the thing is that there's a sweet spot. It's about 6 attometers. And the energy comes out at a rate that would accelerate itself to a relativistic velocity in a period of years to decades. Mm-hmm. It would weigh about 1 million tons. Mm-hmm. Its radius would be at the extreme limit of what you might imagine a gamma ray laser, being able to focus on.
I've never actually imagined that, but I'll take your word for it.
Well, one of the problems is the quantum mechanical thing, that radiation has a limit to how finely it can be focused, depending on its radius.
I'll take your word on that too, but let me interrupt with a question. So, is it possible? Here's a problem I had with the conjecture that I had in my mind when I was talking to Lee about this. What I was thinking was, like, if life is involved in the replication of universes, that could explain why evolution does seem to natural selection is this very inventive, creative process that creates more complex forms of life, more intelligent forms of life. And although, as you pointed out, in the case of our planet, it may have benefited from some disruptions, it seems like a process that is not that unlikely to create an intelligent species if given enough time. And so I thought, well, if life's getting to the point of intelligent species is a prerequisite for the creation of more universes, that could explain why natural selection is so good at doing that. But then I thought, but what I'm saying here is that this intelligent species that replicates the next universe might fiddle with some things such that the next version of natural selection was even more conducive to say, okay, we want to use these base pairs next time around. But my question is, could this intelligent civilization that wants to build a new universe, could it get this information through a black hole?
No, information doesn't come out of black holes.
Well, then a lot of what I like about the theory is not working.
Okay, no. The constants of nature are extremely fine-tuned for reasons that we do not understand at all. We do not have a theory that explains them.
Mm-hmm.
But biological evolution rests on the foundation of physics. Chemistry is just the physics of atoms and molecules. And somehow the physics in atoms and molecules gives you one kind of molecule that can replicate and store information, another kind that can do almost anything, that's like a universal kind of toolkit, and another kind that can take the information from the first kind and use it to reproduce the second kind.
These are three kinds of, you said molecules, or three kinds of physical?
Yeah, DNA.
Okay.
RNA.
Right.
Protein.
Right.
And then mitochondria. Now, why did some random process with atoms on the surface chemistry of a planet produce this peculiar combination? And there are people who try to study this. Once upon a time, people had the idea that there was a natural tendency toward order, and it would be very robust. There was this guy Prigogine who thought there was a fourth law. It's wrong. What they've discovered is that very peculiar, very special systems have this tendency toward order. But if you ping the system a little bit, you get nothing. So it's much more likely, based on computer models and studies of things like that, that there's actually something very odd about organic chemistry, that it would produce something like that instead of just turning into sludge.
Mm-hmm. So
that would be fine-tuned in the coupling constants of nature.
Well, could this intelligent civilization that's engineering a new universe, could it in any way influence the those constants or anything that might in turn increase the chances or the frequency with which life originates or the efficiency with which it evolves? Is there any kind of tinkering the intelligent life could do to make that next universe even more conducive to intelligent life than the first one had been?
Well, think about the chicken. The chicken doesn't deliberately try to make a better egg, but in the long run it comes out like that. So what it would be that, so here's, you see, what I really work on is trying to find the unified field theory. That's a whole nother.
We'll save that for another conversation.
Yes, absolutely, right. But the thing is, we need a quantum theory that unites gravity with matter in order to understand what happens near the singularity of a black hole. It's really, we don't really know if there's really a singularity or not. And quantum effects could change that. And we don't know what happens to the laws of matter when they go through the singularity and come out the other side, if that's what happens. There's some arguments that say it doesn't. So, there's a lot of uncertainty to all this. We don't, we're really pushing our theories beyond where they've been tested, and there's things.
Okay, so do I understand you to be saying that, on the one hand, no, there's nothing that the intelligent species could do to intentionally make the next universe more conducive to life or to the evolution of intelligent life or anything, but it could be that in the course of creating a bunch of black holes, each black hole might, through a kind of a random mutation, at least create variety, so the more black holes you produce, the more...
Yes, exactly.
Okay, and so in that scenario, what the virtue of intelligent life is that it creates more black holes, and then... the black holes, the baby universes that get selected out and preserved because they're good at further replication are in fact those universes that were, through random mutation, even more conducive to the origin of life or evolution of life.
Okay, let me tell you stage 2.
But was that more or less right, what I said?
That's right. That's it.
Okay.
That's it. That's the idea. Okay, so the next stage, I realized I started getting interested in interstellar travel. So the situation is, there have been a lot of proposals for building starships, and they've been studied, and none of them would work. We don't know how to get to the stars. Okay? It's very hard.
Yeah.
Anything that people have thought of, there's just something that won't work about it. Okay? So it may very well be that the only real way to build a starship is with a black hole. It's the most intense energy source we could imagine building.
Now wait. If we just establish that in the course of building a black hole, like you can't get any information through the black hole, so to speak, it's like not clear to me how a black hole becomes a part of the very intentional engineering project that the creation of a starship would be.
Okay, the point is, look, you make a black hole. In principle, it's very simple. You just have to get a whole lot of stress energy, matter. I'm being careful not to say mass because Einstein's equation is a tensor equation. So it doesn't need to be rest mass, but matter, energy, to concentrate in a very small volume. And once it gets within its own Schwarzschild radius, it causes a black hole. And then the black hole radiates. So if you made a very small black hole and it was very hot, it would be a very intense energy source. And then you could use it as the drive
fuel
for a black hole starship.
Fuel.
So if you look up my name and also my student Sean Westmoreland, who worked with me on this,
you're mainly a starship designer. Is that what I'll find?
Well, you'll find some stuff about starships, and I won an award for an essay proposing this, and so the thing is that we figured out there's a sweet spot. There's a size of black hole you could just imagine creating, and I think nature does us a favor. It's just outside of possibility, but then there's this sort of little physics miracle that makes it possible. And that's what we call the nonlinearity of vacuum. That if you see, the idea of making it is to have a gigantic imploding laser. Mm-hmm. And you have an imploding electromagnetic front. The front would have to weigh about 1 million tons. So you want to think of the gamma ray lasers weighing about 1 billion tons. All of this is back of the envelope. Mm-hmm. It would be very silly for me to try to calculate anything more precise at this point. But then it shrinks down within its Schwarzschild radius and makes a little black hole. And then you use the radiation from the black hole to guide it, and you put it into like a little trap, and you reflect the energy out and use it as like a photon drive to drive your starship. So this is the answer to my second question, if you remember. Why do we want to build them? We want to build them because there's no other way to get to the stars. The other suggestions, believe me, are much worse than this. We can't do it now. It would cost $1 quadrillion. And again, that's back at the envelope, and I absolutely refuse to try to do that. It's more money. Expensive. Yeah, it's more money than we've got. Mm-hmm. But 200 or 300 years from now, I mean, I imagine myself in the same position as Leonardo da Vinci. Okay? He goes to the Duke of Florence and he tells him, I've got a great design for an airplane. And he unwraps a scroll and he's got a 747. And the Duke looks at it and says, that's very nice. How much would it cost? And he says, 1 billion florins. And the Duke says, you know what my budget is this year? 60,000 florins. It's very nice, Leonardo. Couldn't you paint some more portraits? That would be what Leonardo would get with his... All right, but 400 years after Leonardo, mm-hmm. we built the damn things and the planet's full of them.
So you may be vindicated, but not in your lifetime.
No, absolutely not in my lifetime.
That's sad.
Well, I mean, do you feel sorry for Leonardo?
No, you make a good point. On the other hand, he did get some things funded even in his lifetime, I think, and maybe you are too. Let me ask you a question. So there's lots of black holes. There are black holes out there apparently, and they were not necessarily. What's that?
They don't radiate significantly,
but we think they're out there.
Yeah, we see them.
And
Wait, sorry, let me explain. There's two different things.
Sure.
There's matter falling into the black hole and radiating,
Uh-huh.
and we can see that. But you see, there's the Hawking radiation, which is where, because of the curvature of the space-time, virtual particles get separated and radiation comes out. And then the black hole slowly radiates out its mass energy, and then goes off in a final explosion, if we believe the semi-classical theory, which is all we've got.
But meanwhile, something happens on the other side, so to speak. I mean, there is this prospect of creating new universes.
In the classical solution, a singularity forms, and if you maximally extend it, a new universe forms on the other side.
And is the definition of singularity in this context something about just an inability to see what lies beyond it?
No, it means that the radius of curvature becomes zero, so the curvature becomes infinite.
Okay.
It's infinitely bent.
Does the phrase event horizon enter this?
This is inside the event horizon.
Okay, well, I'm glad we got that straightened out. But okay, so here's the question. So,
there's a very nice book by Hawking, The Large-Scale Structure of Space-Time.
Okay.
Do you know it?
I'll put it on my list.
It's got really good pictures. You can just look at the pictures.
That's what I look for in a book. So, so in your scenario, is it both the case that the universe creates some black holes of its own accord, so to speak, without intelligent life being involved, but intelligent life can greatly increase the number of black holes?
Okay, suppose this scenario is correct. So you can make a black hole, and you can use it to get to another star. You get to another star, you go live on the planet. And after a couple of generations, you get tired of it, and you build another laser, and you build another starship. So it causes a plus, aside from being a drive for a starship, it's an ultimate energy source. You can throw in garbage and out comes energy. The black hole will absorb anything and turn it into energy. So we're going to build zillions of these. So the universe is going to be, as we expand, it's going to be full of them. So that's lots more than there are stars.
Okay.
They'll be everywhere.
So and does that in turn, so the intelligent life is in this scenario like spreading across the universe, and that is further increasing the prospects for like more black holes and more and blah blah blah. Now tell me this: is it like these black holes that turn into other universes? Are those the same black holes we're creating just as the fuel for the starships, or is that a separate? Oh, I see. So it's just like a nice byproduct.
Yeah.
Okay.
Yeah.
So now
my point of view has no point of altruism. I don't know. There's nothing in human history.
And this distinguishes you from Harrison, right? We referred to Edward Harrison, who died in 2007. He was a cosmologist, and he published a piece, I guess, in 1995 in a journal that had so in his version, it's like a conscious decision to create other universes. But look, why couldn't it be?
It's a constant decision to get rich, to travel, and to keep warm. I mean,
so you have a more cynical view, but I don't get.
Well, I'm sorry. Do you read history? I mean, cynicism versus altruism. What's the scorecard look like?
Yeah, but there is something about people like the idea of the perpetuation of the lineage.
Yeah, that's true. I think it might give people. So the thing is, for the human race to start doing this, I mean, you would have to build something the size of a small asteroid that's as precise as the gravitational wave detectors that are scaled down to nuclear dimensions. And I said in round numbers, so you would probably have to make the laser in lots of tiny, very small tubules that you would have to all align, because otherwise the heat dissipation would be a problem. I mean, so one of these would be like a very, very high-tech nuclear explosive that explodes, lasers when it explodes, and you would have to correlate them. And if you think about one of these as being about as heavy as a car, the industrial task of building enough of them to get within its Schwarzschild radius would be comparable to making all the cars in the world today.
Mm-hmm.
Okay, so about 1 billion. Think about building 1 billion cars. That's the size of the task. So it would be as big as it would be like 10 times the dimensions of the pyramids, and it would be ultra precise. And it would take us centuries to build. We would have to build a space-based industrial base to use solar system resources. We couldn't think about doing it on Earth. It's a long task that the whole human race would have to work together on for generations.
Okay.
So, but then if we did it, we reproduced the universe, and our progeny spread all over the galaxy.
Right. Well, earlier we're saying that, our civilization, it may be the case that most civilizations die out and we don't play a role in any replication, but there's a chance that if we play our cards right and overcome all the tribalistic impulses we see at play and so on, and don't let weapons of mass destruction destroy the planet and so on, we might play a role.
Oh, you're so out of fashion. Global warming is the new...
Don't get me started. I personally think, as important as global warming is, I think we're more likely to blow things up through hatred and weapons, but we'll see. But anyway, the point is...
I think stupidity is just as bad. It's probably worse than evil. But, I mean, the thing is, we've done such a wonderful job already on the global warming, just completely by accident.
Yeah, but the great thing about global warming is when you finally try to do something about the problem, it does tend to make some progress towards solving the problem, right? It's not... Whereas with, like, the war on terror, whatever you want to call it, everything we try to do about it actually makes it worse. So it's a positive feedback cycle of ever descending catastrophe. Whereas like global warming, once it finally gets your attention, it's not like the things you do actually make the problem worse. They make the problem better.
Okay. Well, perhaps doomsday scenarios are a matter of taste.
Okay, so let me anyway, what I was going to say was...
But anyhow, the point is, wouldn't we be much more likely to avoid these things if we had an overarching sense of unitary purpose?
Well, that's my point. And isn't it better? Isn't the purpose more inspiring if it's actually to create other universes than if it's, I mean, not to trivialize the building of a starship, than if it's just the building of fuel for a starship, right?
Well, okay, I mean, they come together.
Right. They
don't get one without the other.
Right, but we might as well tell people, hey, it's a twofer. Sure, it's a starship. It's like it's a breath mint, it's a candy mint. I don't know if you're old enough to remember the Certs commercials, but it's a starship fuel. It's a baby universe.
Yeah, no, I know. But see, the other thing is, we are getting very close to the point where we're going to start finding out where the Earth-likes are, and then the Earth-like planets.
Oh, sure.
They're starting to discover them now. And the next generation is going to have pictures of Earth-likes. Now, how would that feel if there was like a very attractive Earth-like that we could live on, and it was just a measly 10 light years away? It's starting to look like they're all over the place, but you still can't get there.
Fire up the black hole, yeah, absolutely.
And then I really do think there are two classes of theories of how to build a starship. There's the ones we know won't work, and there's the ones that depend on physics we don't believe in. People are willing to just pretend that physics is differently than what we think it is, because at some level they want to go to the stars so badly, they're willing to say, let's use negative energy. That's nice. Explain to me where you're going to find negative energy. Matter is positive energy. All matter is positive energy. Where is this negative energy supposed to come from? No place. But they're willing to design, So this is just on the limits of what's possible based on physics as we know it. So I really think, I haven't tried to debate this a lot with people. It isn't something for immediate practicality, that it's the least worst suggestion. If we're going to get to the stars, this at this point is the best idea we've got. And people are going to want to get to this. I mean, did you see the 16-year-old girl in Holland who sailed around the world by herself on a ship?
I didn't, but I'm impressed.
Yeah, but the thing is, what's she going to do when she's 17? If you can sail around the world by yourself when you're 16,
no mountains left to climb.
Then the world isn't big enough for us anymore. We need more room than that. You know, I mean,
so you said that, okay, like the actual starship travel, which is the real payoff, is like 400 years away or something. And so the question is, right now, in terms of things we could be doing to facilitate the eventual realization of that goal, one is a big one, I think, for civilization to survive, keep our act together, keep progressing intellectually, technologically, not blow each other up. Now, okay, so that's one thing. But
those would all be nice.
That would be nice. But beyond that, I mean, like if you were asking for funding for yourself, like if I were in charge of keeping the world together, and you could like do the science and engineering part of getting to that starship, would you be doing exactly what you're already doing, or is there something you could do with more funding?
Okay. I'm actually working on the unified field theory because this was just an aside that Lee Smolin sort of dragged me into. But then I just couldn't, I couldn't, your ideas become your children and you become responsible for them. Mm-hmm. But the next thing, I tried to get a grant out of the Applied Math Division of the National Science Foundation to do research into calculations in a nonlinear vacuum. Because, you see, if a grazer will not have high enough frequency to get inside its own the Schwarzschild radius for the sweet spot. But the thing is, when the concentric beams started crossing, they would get into the region where electromagnetism is nonlinear. But now we know there's something called the Euler-Heisenberg-Lagrangian from the 30s. People studied this. And it turns out that light becomes sticky. It's exchanging electron-positron pairs is what it is. Mm-hmm. But it becomes sticky. And so it becomes a very powerful attractive force. And in fact, the differential equation is very similar to general relativity. And there's a small genre of people who study that kind of theory because it's like a baby model for relativity. It's a very interesting mathematical model. I mean, I could tell you what's interesting about it. But,
so you applied for this thing.
And I got back a rejection in which somebody said, the purpose of it is this is applied math, right? The purpose is to design a black hole starship. I recommend denying funding. And I wrote back and he said, well, what's your point? But so obviously their point of view is that you're supposed to be, if it was something you could kill people with, there'd be no problem. But they just thought this
suggests a starship with guns. That's the obvious solution.
Okay, well, all right, I didn't do that, but it wasn't funded. And they said, well, the problem is completely novel. It's an interesting partial differential equation. Nobody's ever studied it. It does have these interesting mathematical properties, but build a black hole, get real. We're not going to fund that. Mm-hmm. Not even as a study in pure mathematics. It wasn't pure, it was applied math, right? So I've had nothing but bad luck.
Okay, well, maybe when this...
So, but actually, at this point, I'm not interested in working on it. I was thinking of getting another graduate student to work on it, but I'm hot on the track of the unified field theory now, and I'm working on that. It's a completely different problem.
Well, good. I'd actually like to have a conversation about that down the road. But first, before we finish with this conversation, let me just ask you two questions. There's a lot of enthusiasm about simulation scenarios, like, are we in a simulation? And there's a kind of, okay, you look as if you're not enthusiastic. Although a good example, I'll tell you what, I wouldn't dismiss this too casually, because the kind of person you might be able to get funding from is like Elon Musk, the guy who makes Tesla cars, and he's a big proponent of the simulation. He thinks the chances are overwhelming that we are not in, quote, base reality. Anyway, here's my question. In these simulation scenarios, if we are a simulation, if our universe is a simulation, it seems still possible that we could get to a point where we could produce a simulation as complicated as this universe, and that is kind of a similar, in many ways dissimilar, but it is a scenario where universes in some sense replicate themselves. Okay, technically they're simulated, but you don't know the difference from the inside, so you don't resonate to this idea?
I really seriously do not. It sounds solipsistic. You know what Schopenhauer said about solipsism?
I don't.
Okay, he said, solipsism is like a fortress in a war, which cannot be assaulted frontally, but can be safely bypassed and ignored.
Okay, of course, the simulation enthusiasts would say, no, solipsism is assuming this is all real. How centered of you, so to speak. But, okay, second question,
okay.
Final
Let me
question.
give you some advice.
Yeah.
If it really is a simulation, and you notice some little glitch where you've caught the computer programmer, pretend you don't know and don't say anything, because he's going to rewrite it and he's going to write you out of it, okay? And it'll just be like you never existed.
No, I would have been very valuable to him if I'm spotting bugs. He'll give me a raise. So
he might put you in a subroutine and turn you into a demon. I don't know. I
think he would replicate me a million times over. I'd be delighted. But final question. So there are all these. It looks increasingly like there are actually a lot of planets out there that are conducive to the evolution of life. In your theory, there's reason to think that actually life probably becomes pretty good at evolving over time, and has done that by the time our universe showed up. So the question now, presumably, on many of these planets, things moved along a little faster, so they're like ahead of us technologically, in some cases way ahead of us technologically. So, and maybe you've heard this question, why have we not been contacted by some of these civilizations?
Okay. First place, it's quite possible that when you look at all the improbables, not just to create bacteria, but to actually come out the other side with intelligent life, it's like something on the order of 1 to a galaxy. So the others would be billions of light years away and we wouldn't see them. Okay. But I actually, in my paper, my joint paper with my student, I proposed something we called gravicetti, which is that if somebody is making these black hole starships, they would be emitting gravitational radiation at a very, very high frequency, which no natural process would do, because they're tiny, and yet they're very violent. So we could build, instead of building, you see, gravitational wave detectors have to be fine-tuned for looking for a particular frequency. So they've been building very long ones because they're looking for things from collapsing stars and so on. But this could be much shorter if it was looking for a much higher frequency, and you could then scan for it and you could see it. So it could be that if there are some of these things, we could find them. So we could discover, using gravitational means, if this is correct, we could discover if there are advanced civilizations otherwise in the universe. And other than that, we wouldn't be very likely to see them, except in the very wise alien scenario. The very wise alien scenario is that they're bopping
That was going to be my next question, by the way.
Okay.
Proceed.
Bopping along in the universe, and then they see us. They get a good look at us, and they turn and go the other way as fast as they can. And then we would see the gamma rays, the collimated gamma rays from their jet as they departed the premise.
Or they just observe us from a distance. They don't want to interfere. Or maybe like interfere just occasionally, like to get you funding, but not aside from that. Something like that.
Right. Well, I mean, okay, I don't. At the moment, what I'm doing doesn't need funding. I mean, this would, and I could, if other things had gravitated to it, I could have done it perfectly well without funding. It's math. It's the things I can think. The other things that you could do if you really wanted to try to pursue this would be to try to develop different kinds of gamma ray lasers, to try to produce gamma ray lasers that would focus. And you might eventually try to produce gamma ray lasers that were powerful enough that you could start to see the nonlinearity of the vacuum. So that's something.
Well, would that help you build a black hole or something?
Well, yeah, then just make a billion of them and figure out how to collimate them all, and you've got it.
Okay.
It's just
and then what do you do with it? Huh? What do you do with the rest of your life though once you've accomplished that? It's like the girl who sailed around the world.
Well, I'm not really worried about what do I do with the rest of my life. I'm actually rather old, and I had a heart attack 3 years ago. I don't know about the rest of
Okay. Well, then in that case, then I think you should stick with developing the unified field theory.
No, but the thing is, building one or two of these and trying to push it up to the point where you have gamma ray lasers. The other thing you could be working on is trying to find ways to store. There was a small discussion about my proposal, and people pointed out you would really want to find a way to build nuclear batteries because you have to store up all this energy. And it might be the laser could be used to store it up itself, or you might be some more indirect process where energy gets stored by exciting nuclei, and then they all give off at once and excite the laser. I mean, all right. So people could start to experiment with things like that. Building one might be just a bit beyond our current technology. But the thing is, building 1 billion tons of them and collimating them is the thing that it's just too big of a job for it. I mean, the only thing that's really impossible about building it right now is that it's too big and too expensive. Other than that, it's just a bit beyond what we know how to do. You would like to increase the power of your gamma ray. I mean, the other problem is that gamma ray lasers are classified because they can be used to shoot down ICBMs. So I don't know what's known about gamma ray lasers.
You don't have that kind of classification access. No. Neither do I. So, well, listen, I think...
I promise you the military doesn't give a good goddamn about what I'm doing.
I got to admit, it's kind of hard to imagine you, like, walking around the Pentagon and but you never know, put a coat and tie on, try it.
There was a 100-year starship thing. I submitted a proposal, but I said mine is going to take 500 years, so they didn't. It was very funny. Yeah,
people have such short time horizons.
I know.
I'm telling you, Elon Musk is your man.
Well, I don't need any money.
Quit bad-mouthing the simulation scenario. You want to stay in his good graces. He's a visionary. No. He's a visionary billionaire. That's what you... No, you don't need. You don't need money, so you're fine. Well, listen, this has been great. You've given us plenty to think about. We will link to your papers about this, and for that matter, any other papers you want us to link to. Is there anything else you want to advertise? Like, do you have a Twitter feed or any...
No, I'm not.
You're not like that?
No, I'm just very quietly trying to explore a different avenue toward the unified field theory than what the rest of the community is doing.
Okay.
And not telling people about it very much, and just I'm often in this long. I mean, I'm in phased retirement, and I'm working basically full time on that.
Well, if you're not going to do flagrant self-promotion, I'll do a little. People can subscribe to this, The Wright Show. They can subscribe to the podcast. They can watch the streaming video on Meaning of Life TV or Blogging Heads TV. And if people rate our podcast highly and review it on iTunes, we love it. And listen, I would love to down the road have another conversation with you if you have time. Maybe figure out this unified field theory thing.
Well, it's very mathematical.
Well, you never know. Maybe I would ask exactly the questions that would make it accessible, and who knows? Maybe I would give you the key insight that you've been lacking. You don't think so? You don't look persuaded.
Well, it's down to a very, very knotty mathematical problem, and that the other physicists wouldn't even be looking at it because they don't do that kind of math. But I don't know. I mean,
I'm in favor of it. Let me just say that I
Okay.
support you in your endeavors.
Okay, well, that's very okay. Well, I'm a professor in Kansas State University. I guess you could give people my email. Well, I don't know. Is that a good? How
Well, it
big is your
depends.
audience?
Do you like emails from cranks?
No.
Your email address, I believe, is on the Kansas State website.
Yeah.
You are at Kansas State. You are a mathematician. People can Google you, and they can Google meduso-anthropic principle, MEDUSO dash anthropic principle, and they will. There's a Wikipedia entry and everything.
Or they can look at my name, or they can look at black hole starships on Google.
That
There's
too.
a bunch of back and forth about why it's people saying why it's impossible or why it's possible or whatever. And there was it briefly went what do they call? They don't call it
Viral?
Viral. That's the word. Yeah. And in fact, my student told me, "Oh, it's gone viral," like 3 days after we published
You
it.
didn't know if that
And
was
I
good
looked.
news or bad news?
Huh?
No, go ahead. Sorry.
Well, I didn't care one way or the other much, but I looked, and there was one article in Vietnamese, and there was another one in some language in Central Asia that I couldn't identify. So it went all over the world in a hurry, and then I guess it disappeared. There was even a rabbi saying that my theology was acceptable because it drew on Spinoza. One of my papers is entitled Starships and Spinoza.
Huh. Maybe we'll have a conversation about that down the road. We've had a couple of Spinoza chats on this website.
Right.
So,
okay.
but listen, thank you so much. This is fascinating. I'm going to get back to keeping the world intact, and I'll let you build the starship.